Okay, now using substitution with definite integrals. Okay, it's basically exactly the same. First, I'm going to use substitution to find the antiderivative and then I'll plug that back in. Okay, Khan Academy does this slightly different again, but you can do it either way, whichever way works best for you. What I like to do is just use the find the antiderivative, use substitution, then deal with the limits later. Derivative of x squared plus 5 is 2x. We can see we almost have a 2x there. Okay, so that's step one. We use substitution like normal. We find that this. That this is true. Okay. Now, the fundamental theorem of calculus says that this thing is the antiderivative of this evaluated from 0 to 4. Here we found the general antiderivative. So we have 1/3 3/2 there. And now we can just evaluate. This thing with a 4 in it, subtract this thing with a 0 in it. See, that's 16 and 5, that's going to be 21. Okay, a good enough answer for me. You could use a calculator at this point to approximate the answer. Let's do one more. Now I see a couple things in this problem that whose derivative is also in the problem, right? The derivative of sine is cosine, derivative of cosine is negative sine, so almost in there. So then you think about, well, which one do I want to do? You might just try one, and if it doesn't work out, then try something else. But when I look at this, I think, okay, I think I'm going to have a hard time with is the cubing of cosine. That's the issue here. So if I can make that into a u, then all I have is u cubed. And I know how to deal with that, power rule. And hopefully things will cancel out. Okay, so I'm just going to go with that, see what happens. Negative sine x dx. So then we see du over negative sine x equals dx. Alright, so I'm going to deal with this thing without the limits of integration, just the antiderivative, then plug the limits in. Okay, so this is now u cubed times sine x. We found dx was du over negative sine x. So you see the signs cancel, there's a negative. Pop that negative out to the front. So now we have negative integral u cubed du. Easy to take care of now. U to the fourth over 4 plus c. See, my u was cosine, so negative cosine x to the fourth plus c. If I write cosine x to the fourth, another way to say that is cosine to the fourth x. Okay. Let's see, our limits I think were 0 and pi over 2. We just found the antiderivative of this thing, of this expression, to be this guy here. So we have negative evaluated from 0 to pi over 2. Okay, so let's see, we got negative 1/4 of cosine pi over 2 to the fourth power. That's what this means. When we write cosine to the fourth of something, we mean cosine of that something to the fourth power. Plus minus minus makes a plus. Let's see, at 0, when we at 0 over 1 up 0, cosine is the x-coordinate, so this is just a 1. 1 to the fourth is 1. So we see we have, or 1/4, yeah, 1 to the fourth is 1, and then 1/4 times 1 is 1/4. Okay. Now pi over 2, we have over 0 up 1. Over 0 up 1. Cosine pi over 2 is the x-coordinate, so we have negative 1/4 times 0 to the fourth. So this is all just a silly 0. 0 plus a fourth is